Sometimes instead of being given a graph, we're given a system of inequalities in written form. We can still determine if an ordered pair is a solution of the system by plugging the ordered pair into each of the inequalities and seeing if the statement is true. If all three are true, then it is part of the solution to the system, and if even one of the inequalities becomes false, then it is not part of the solution. So let's take a look at the point 0, 0. Remember x and then y. And so we're going to plug 0 in for y and for x in each of these inequalities and see if the statements are true. Plugging into the first one, we get 0 for y is less than or equal to 2 times 0 plus 3. That's going to reduce to 0 is less than or equal to 3. That's a true statement, so I'm going to put a check mark there. The second one, y again is 0 greater than 4 times 0 minus 2. That's going to reduce to 0 is greater than negative 2. That is also a true statement because 0 is greater than negative 2. It gets a check mark. Finally, I'm going to say that 0 for y is less than 0 minus 2. That will reduce to 0 is less than negative 2, and that is not a true statement. 0 is greater than negative 2. Because one of the inequalities was not satisfied by the ordered pair, we have to say that no, the ordered pair does not satisfy the system of inequalities. It's not a solution because it doesn't satisfy the last inequality. Let's take a look at another one. This time x is negative 1 and y is a positive 1. So we're going to plug those in to each inequality and see if it's a true statement. Starting with the first one, 1 for y is less than negative 2 times negative 1 plus 3. The math is getting a little more complicated here, so I'm going to go ahead and do an intermediate step here where I combine all of this. Negative 2 times negative 1 is a positive 2, and plus 3 is 5. My inequality reduces to 1 is less than 5, and that's true. 1 is greater than or equal to negative 1 plus 2. That will reduce to 1 is greater than or equal to 1. That is also true because 1 is equal to 1. Finally, for the third equation, I again have a 1 for y, 6 times negative 1 for x, minus 8. That reduces to 1 is greater than negative 14. That is also a true statement. Since all three statements are true, we can say that yes, we have a solution to the system of linear inequalities with the point negative 1, 1.